Let's start out by using a lot of the theorems. The maximum number of zeros is the degree, so it will be 4. The number of positive zeros is the number of changes in sign of f of x or less that by 2's. So we start out positive, here it changed to negative, and it changes back to positive. So we have 2 or 0. To find the number of negative zeros, we look at the number of sign changes in f of negative x. We start out positive and we go to negative, then we're back to positive. So again, it's 2 or 0. Now let's look at the possible rational roots. To do that, we take factors of our constant term, which is 15, over factors of our leading coefficient, which is 2, and we take plus or minus those. Factors of our constant term are 1, 3, 5, and 15. And the factors of the leading coefficient are 1 and 2. So we're going to have plus or minus 1, plus or minus 3, plus or minus 5, plus or minus 15. Those all have our denominator 1. Now let's divide by 2. The purpose of that is it gives us zeros to try, just to plug them in and see if they work. And to make plugging them in faster, we'll use synthetic division. If the remainder is 0, then we've got a 0. Now 1 and negative 1 are good ones to start with because the arithmetic's not too bad. In fact, we probably don't even need to use synthetic division to do these. So negative 1 is a 0. Now we want to take f of x and divide it by x minus a negative 1, or x plus 1. It's going to give us a smaller polynomial, and it'll be easier to find the zeros of the smaller polynomial. So let's use synthetic division. So this tells us that our f of x equals x plus 1 times 2x cubed, drop our power down by 1, plus 3x squared minus 32x plus 15. I'm looking for the possibility of factoring by grouping, but that's not going to work. Our possible rational zeros don't change because our constant term and leading coefficient didn't change. And we know we have at least one negative 0, so we do have another negative 0. So let's keep doing synthetic division. We might as well try 3 and negative 3 next. And 3 works. So now we can break this down even further. We have x plus 1, x minus 3, and from our coefficients here, we have 2x squared plus 9x minus 5. Well, this is a quadratic equation, and we can use the quadratic formula for that. Get 1/2 and negative 5. So now the original question asked for zeros and also for the factored form of f of x. So our zeros are negative 1, 3, 1/2, and negative 5. Our factored form, we have f of x equals x plus 1, x minus 3. We're going to have an x plus 5. Now the tricky part is the 1/2. If we had an x minus 1/2 here, some of our coefficients of the original equation would be fractions, and they're all whole numbers. So what coefficient would still give us a root of 1/2 but not have fractions in it? It would be 2x minus 1 rather than x minus 1/2.